Hi everyone, welcome back to Mrs. Shin's math class. Okay, let's get started. Today we're going to learn the chain rule. It's part of differentiation, so we have learned it. So let's see what the chain rule is. Okay, let's have a look at this example. If I want to differentiate it, how would I do it? Yes, obviously I need to expand the bracket, remember? Good. Like this. And then what do? And then I differentiate term by term. Remember, if I'm differentiating the function y, it's always dy over dx, which means differentiating y in terms of x. Like this. Okay, but we're learning chain rule today. How do we apply chain rule? How do we make this one a lot more quicker and efficient way to solve it? Okay, so on the right hand side, I wrote down exactly the same equation to the left hand side, that one and that one. Using the chain rule this time, I'm going to try to solve it. So first thing, what you need to do is that you see that squared outside the bracket, I'm going to pull it down there. So, okay, so without expanding the bracket and simplifying, to differentiate the equation, straight away what I'm going to do, having the bracket, I'm just going to simply pull down to in front and keep the bracket as it is. But what's different is you have to differentiate once again what's in the bracket. So if you differentiate what's in the bracket, what would it be? Obviously you have to multiply by 1, right? So x will be 1 and 1 just disappears. Right? So it's just 1. So you're just multiplying whatever was in the bracket, whatever you differentiated from the bracket. Okay, so that's what it is. So if I just expand the bracket and simplify, ta-da, I'll get the same answer, right? Much easier using the chain rule. Okay, should we try once more? I want you to have a go at doing this one. Right, the first step is you differentiate it, pull 3 down, and what happened to that 3? Obviously, what did we do? Yeah, you have to minus a power, so that becomes 1. Normal differentiation, right? So 3 minus 1, that will be? Yeah, that's right, 2. Okay, now, what do you have to do? I have to differentiate what's inside the bracket, 5x minus 1, right? So what would you get if you differentiate 5x minus 1? Yep, I would get 5. So I'm just multiplying 5 onto it. So if I just rewrite the equation, obviously 3 times 5 will be 15. So therefore, inside the bracket, 3 minus 1, 2. So therefore, that will be your final full correct answer. Easy, right? Okay, let's have a go at doing fraction. Alright, how would you use the chain rule for this one? Obviously, you have to make it into negative power. So that one goes up, then it becomes a negative power. Okay, remember this rule? You're just applying this one over here. That one goes that fraction into negative power. Okay, and the next thing is you just pull this one down and multiply with this one, differentiate this one, pull it out and multiply together to use the chain rule and to solve the differentiation. Yep, you okay so far? So pull that down, multiply negative 12, and negative 4 minus 1 should be negative 5. And I need to differentiate this one, which would be 2. So over here, I'm just going to write 2. And I can simply multiply these two together like this, okay? But would you leave your answer like that? You should put it back into fraction form because we never put negative power as it is. So put it back into the fraction form. So that one will go down looking like this. Okay, so let's have a look at another example. In this case, you have two different functions, function of y, function of u. Okay, so that u is over here, so simply you can just substitute the value in and use an easy chain rule, right? Yep, just like this. So what I've done is I just substitute that value in there like this, and I use the chain rule, pull down the 5, 1 power, you minus 1 to the power, you differentiate what's inside, which is negative 2x, and I'm just multiplying these two, which will be 10x to simplify to get the final answer. However, let's try another way. Our main goal here is to get dy over dx. However, how should we get dy over dx when we have two different functions, which is y and which is u? Okay, let's have a go at differentiating this first. If you differentiate it, it's going to be differentiating y in terms of u, because the value here that I'm differentiating is u in this function. Okay, so dy over du, it has to be, and 5u to the power 4. How about this one? This one will be du over dx, because I'm differentiating u in terms of x. Okay, and there you go. I differentiated two of them. Alright, multiplying together, can I make it that one? Yep. In order to make dy over dx, okay, I've got dy at the top, so I'm going to borrow this down here, dy over du. Alright, my x is at the bottom, which we want, so I'm going to bring this down, dx du. And if we multiply them, what happens? du, I can cancel it out, right? So all I'm remaining with is dy over dx. We know what dy over du is. We know what this is. So we can just replace with a number. Yep, like this. So that one over here, this one over there. If I simplify this, it would be, there you go. Alright, but I still have u when all my formula has to be in terms of x. Inside here has to be all x, but I have u. So what I'm going to do is, look up here in the equation. I know that u is 4 minus x squared, so I'm just going to simply change that value into that 4 minus x squared. Okay, so final answer looks like this. Let's compare this answer with the previous quick chain rule method that we did. Look at the answer. Negative 10x, 4 minus x squared to the power 4. It's equivalent. So both way is the same way. And these both method called chain rule. Right, then you can ask me, why do you use a difficult way when we can use the easier way of the chain rule? My answer is this one. Have a look at page 94, question 91. Alright, the question asks us to find dy over dx, and it's giving us two different functions, y and p. This looks difficult, unlike the previous question. So therefore, I have to differentiate y first, and I have to differentiate p separately, combine it together to come up with dy over dx. Okay, so before doing that, I don't like fractions when differentiating them, so I'm going to put it back into negative powers, like this, right? Okay, now what am I going to do? I'm going to differentiate each one. Yep, I made it dy over dp, like this. Okay, then you can ask, Miss, why p instead of a when I have two variables? Alright, I want to make dy over dx, right? So it's going to be dy over something, and it's going to be dp over something. If I make it dy over dA, and it's dp over db or dx, if I make it in A, I cannot use a chain rule to cancel things out. So since this one, another function is p, I have to differentiate in terms of p, so I can cancel it out later on. Okay, like this, if I differentiate dp dx, then I can cancel out dp dp, and all I left is dy over dx. Okay, and this one I differentiated, pull it down, -1, and inside the bracket you have to take out, and which will be just 1, but I will still write it just in case I might forget it next time. So always put times 1, even though you don't really need it. Okay, so in order to find derivatives, dy over dx, I know dy over dp, dp over dx, I can cancel it out, so I can just replace them like this. Okay, right, p, the value p, I have it over here. So I can get rid of the value p and change it in terms of x, right? Which is over here. So I'm just going to bring it down and insert it here and simplify this value. Okay, just like this. So p, I just replaced it. Now I'm going to simplify it. Remember negative power from year 12, if we have it outside the bracket, or even if you just multiply top and the bottom, okay, it flips. So if it's outside the bracket, it flips. So therefore, I'm going to rewrite this part as like this, okay. Now I flipped it and negative power disappeared. And same with this thing. It's over 1, so it flips. So it's 1 over like that, using the third rule. Okay, here I just rewrote it. So what I have done is, that's a half, right, to the power of a half, times 3, multiply 3, right? Now 3 over 2, and b, oh, I forgot to the power of 3 over here. So, because it applies top and the bottom. Alright, times a half, not negative 1 over 2, b goes at the top, and this one, I wrote it back into thirds form, but I thought it was just easier to see it in power form, so I just put that one over there. But remember, as I flipped it, put it at the bottom, negative disappears. Okay, so you see that? Now what I need to do is I need to cancel out. First, negative become positive. I can get rid of 2. I can get rid of 1b top and the bottom. Okay, and there you go. These two the same, so I can just cancel out. So all I'm left is a over b squared. So dy over dx, the final solution throughout all this, is a over b squared. Okay, so that was the answer to it. So this is why we learned the other way of the chain rule, because sometimes there are 2 different functions given and it's hard to just merge it together and use a simple chain rule. Okay, so it's the same thing, same method, but just quicker way. Right, I'm sure you want me to show you another question of this one. Okay, so this is question 96, page 94. Have a go at doing this one. I need to find dk over dx, so first thing, obviously, I need to change it back into, negative powers. So have a go. Okay, if we wrote this in a power form, it's a negative power, and this is just 1 over 2 fraction. So I'm going to differentiate this one. It's like that. This came down, 4 times that will be negative 4 over 2, or you can simply say negative 2, and minus 1 to this one, negative 3 over 2, and this one, again, you pull this over, Yep, it's going to be negative a half because you minus 1. And remember, you need to differentiate this one, pull it out, multiply it. So it's going to be minus 1 multiplied. Okay, so I can simplify it. Yeah, and v over here, I can replace it to the v that was on the question. So I replace v. Okay, so likewise, I substitute it back in here. Then a half times that, because it's in powers of power, we're multiplying them, which will be this one. Okay, now we can find dk over dx by multiplying this one and this one, because dv will cancel out, and I'll be ending up dk over dx like this. Okay, so let's have a go. Alright, we came this far. Right, let's have a look at solving this part this time. Alright, 2 and 2, negative and negative. Of course, I can just cancel them out. If you have a look, luckily I have same base of 3 minus x. If I have same base, then what happens to the power? Obviously, I'm adding the power, right? Okay, in here I just made, what I changed is I just made this one into 4, so it's easy to add the fraction. Okay, so it's going to be negative 5 over 4 in the power, but I have negative and 5 over 4 is a fraction, so I can flip it and make it into thirds. Okay, ta-da, and this will be your answer. Okay, so these 3 rules, actually it's these 2, because those 2 are the same thing. However, these ones are essential that you need to remember from last year's math. Okay, so if you forgot about it, please remember, practice them, and make sure you know how to apply it in the questions. Okay? Right, well done. Otherwise, see you in the next lesson. Bye-bye.